Okay, in this question, we have an exponential function here, and this one looks very different to what we're used to solving. We're going to end up using the quadratic formula to help us solve this. So we have to make this a function that is essentially quadratic. Now, at first look, I have two exponentials, which I can't really put together. So my goal here is actually going to be to try to eliminate one of them. Okay. In other words, I kind of want to get rid of this negative exponent here. Okay. One way we can do it is obviously we can flip it, right? We can make it 1 over 2 to the power of x, but we'll still won't be able to simplify this, right? Another way we can do this is by multiplying both sides of the equation. So let's multiply both sides of these equations by 2 to the power of x. Okay. So when we do that, that gives us a distributive property here. Okay. So when we do this, this becomes two bases that are the same, and we add the exponents together, so we get 2 to the power of 2x. In this one here, we have 2, and when we add these exponents together, our bases are the same, we have 2, and we add x minus x, what do we get?
0.
0. 2 to the power of 0 is equal to, and over here we can't really simplify this. The idea is that it's 4 times base 2 to the power of x. So here we actually have a quadratic. So this obviously becomes 1, and I can move this to the other side. So we have 2, and I want you to think of this as 2x to the power of 2. Essentially, I've just split those two up there. Okay, that still works the same. Over here, we have, when I bring it over, subtract 4 times 2 to the power of x. And finally, minus 2 to the power of 0 becomes 1. And this is all equal to 0. So I move this stuff over. Now, this idea here is we can turn this into a quadratic. So let y equal 2 to the power of x. And it'll make a lot more sense this way. Then we end up with y squared minus 4y minus 1 equals 0. So now you see it as a quadratic trinomial. Does that make sense that way? So then from here we can use our quadratic formula. Y is technically equal to our negative b plus or minus the square root of, and I just used y because normally it's base x, but because it's an exponent here, I didn't want to get us all confused. B squared minus 4ac all over 2a. And those values are, our a is technically 1, our b is negative 4, and our c is negative 1. So we're going to plug those values in to help us solve for values of y. So y is equal to, this becomes negative 4, which is 4, okay, for our b, plus or minus. So I'm going to try to do these steps relatively quickly because hopefully you're familiar with this. When we take negative 4 squared, we're going to end up with 16. Negative 4 times negative 1 is positive 4, times 1 is positive 4, so we're adding 4. And all of this is over 2 times a, which is just 2. Okay. Y equals, these values can simplify. I eliminate those, that becomes, oh sorry, no, I can't do that. What am I doing? They're not multiplied by each other, sorry. This becomes root of 20. So we have 4 plus or minus root 20 over 2. We could turn this into root 4 times root 5, which would then allow us to simplify this. Have you done that with radicals before? Yeah. Okay, so we get y equals 4 plus or minus. This becomes root 4, which is the value of 2, times root 5. And then this way, now I can eliminate the 2 from essentially both of them, and that becomes 2. So now we're left with y is equal to 2 plus or minus root 5. Okay, as our answers. Now, essentially that gives us 2 answers, right? We know we can split y is equal to 2 plus root 5, or y is equal to 2 minus root 5. But the thing was, y wasn't what we were solving for. What were we solving for?
2 to the power of x.
Yeah, we're really solving for that x. So let's substitute our y out now. This y will now replace with 2 to the power of x. So essentially, it's 2 to the power of x is equal to 2 plus root 5, or it's equal to 2 minus root 5. Is this making sense so far? Yeah? Okay. So from here, we can then find the, well, we can actually give values to this. Or we could go about finding logs of both sides. So like we're saying, we'll put logs of both. So let's say if I find log of this, this becomes coefficient x of log base 10 2 is equal to the log of base 10 of, and then it's actually all of these values. So we have to actually give it a number. So we'll have to equate that on the calculator to figure it out. And the same idea here, the only difference being, actually let's solve the left side and then go to the right. When we go to solve this, I just bring over my log base 2, so x is equal to log, and we just got to figure out what that value is, divided by log 2, which means if we look at this, the process is going to be the same when we find the logs of both sides. We'll walk through it, but log 2, technically the x comes in front, is equal to log and then 2 minus root 5, which means x will be equal to log 2 minus root 5, a negative sign over log base 10 2. Does that make sense?
Yeah.
And then from here, it's essentially a calculator to give us our values, right? So first off, we actually have to find out what root 5 plus 2, 4.23 we'll say. So we're looking at log 4.23 over log 2. And I think this one's going to be log 0.23 over log 2. And then from there, we'll get our rounded values with our calculator. So this number to log base 10 divided by 2 log base 10 is equal to 2.08. So our x value is 2.08. And our other x value is, I guess we should actually put that value in to be very accurate. 2 subtracted by bracket 5 root and bracket equals. Oh, did I write that wrong?
Oh no, it's
Oh, it is negative.
Yeah.
Sorry, so it is negative. Good. Okay, so we have our value of negative, and then a number, right? So this doesn't even give us an option here. When we find our log of a negative, it is unsolvable, so we only have one answer in the end here, and it's when x is equal to 2.08. We can look at it on a graph to actually help us prove it, and we'll actually look specifically at, let's go back to this version here. Sorry. But we really want to look at, this will probably be the nicest one on the graph when we rearranged it. We rearranged it this way, we can probably take a look at this, right? 2 to the power of x minus 4 times 2 to the power of x minus 1. And we'll take a look at that to see when it's equal to 0. That's essentially its x-intercept. Should be what our answer was. So when we go over, we have 2 to the power of 2x minus 4 times 2 to the power of x. Oops. Power of x, that's right, minus 1 should give us our intercept at 2.08. Okay, and that's essentially our graphical proof of what we just did over here.